Greetings and welcome to Flanigan's Ecologic. I am your host, Ted Flanigan. And this week, Dr. Evan Mills is back. He was on the podcast back in July of 2023. He is an affiliate and retired senior scientist with the Lawrence Berkeley National Laboratory. He's an affiliate and research affiliate, and he's a research affiliate with the Energy and Resources Group at the University of California at Berkeley. He's written a paper called The Emergence of Indoor Agriculture as a Driver in Global Energy Demand. It's absolutely fascinating. Evan, thank you for being back on the podcast.
My pleasure. Nice to see you, Ted.
Very good to see you. And let's just dive right in. This notion of indoor agriculture, we're going to talk a little bit about the history of it, but let's just jump right to the chase. Controlled environment agriculture, or CEA, as you've educated me, produces less than 1% of all the food crops in the United States, but uses more energy than all open field cultivation. Is that right?
It's a mind bender, isn't it?
It really is.
Yeah.
It really is. Okay, so that's point A. And point B is this use of energy could grow to, you estimated, 7% of total national energy use. Correct?
Yeah, that's a what if. That's, just testing the bounds of how bad it could get if everybody went whole hog for this. Yeah. That's only about 15 crops, but those are the main crops that are amenable to it.
I mean, that's right up there with data centers, right? I mean,
It's way more than data centers. It's more than commercial aviation. It's more than the chemical industry. That's a what if. But even today, it's enormous. It's about 1% of U.S. energy today. All sectors. It's not trivial.
To grow 1% of our food crops. Well, let's go all the way back. I enjoyed the history, the first couple paragraphs.
I did too. Yeah.
You said there's been about 10,000 years of agriculture as we know it. It's been exclusively outdoors. But then, in the Roman Empire, they were growing melons in greenhouses that were glazed with translucent stones.
It was a surprise. Part of my due diligence was just how far back does this go, and how has it evolved as a technology, as a practice? And Tiberius Caesar was at the time of Christ, and he fancied they called it a melon, but it's actually an Armenian cucumber. And I'm not sure if his doctor said he had to eat it or he just fancied it, but he wanted it, and he wanted it all year round. And his people, so to speak, they invented this structure with, there was no glass at the time, at least not on window scale. And sure enough, that he produced these cucumbers year round.
Amazing. In the 1450s, greenhouses were heated in Korea. That's a long time ago.
It's a long time ago. And, cold climate, they were beautiful structures. They were earthen structures, kind of adobe, earth bricks. They used waxed paper, very heavy mulberry paper that was waxed oiled to be translucent. And then they burned biomass in these kind of, earthen ovens, and they had tunnels to air channels in the massive floor. So it was very kind of groovy, sustainable, renewable kind of a heat. And that was, the mid 1400s, so that they could extend. So both of these were about extending growing season, dealing with the harsh climate and increasing yields.
And that in the 1960s, widespread use of controlled environment agriculture in Norway, Russia, Sweden, later Holland, Japan. I mean, all this to extend the growing season.
Yeah, electricity came. So in the late 1800s, there was electric lighting. Russia, other parts of Northern Europe came, and then came these buildings. And as far back as the 60s, which is quite a while ago, and there were, Herculean, fantastical buildings. The Poles designed 5-6 story greenhouses. They built a few. These visions, of space age agriculture way back then. So it's not new. It's new in the 10,000 year time frame, but society's been dabbling with this for a long time.
And then you make your paper is what you call it, a meta-analysis, and you took 116 publications and synthesized them together. One of the distinctions that you make early off is between sort of greenhouses that we all are familiar with, and some of them have open windows and sides, and then these closed windowless structures that you call plant factories, or are known as plant factories, right? Those are really the ones that we're honing in on, right?
Well, the greenhouses too. Greenhouses, one part of the problem in this space is that there's all this jargon and naming, and most of it's quite
Mm,
ambiguous, and there's a lot of distinctions to make. And so I always called it indoor agriculture,
yeah.
but controlled environment, they're controlling the environment, light, heat, humidity, different things. But there are greenhouses, like you said, that are open. There are ones that are closed. There are greenhouses that are highly mechanized. They're heated, they're cooled, they're lit. So greenhouses are among those using energy that is, needs to be picked apart. And then some of the factory farms or the plant factories, their words are used: precision agriculture, vertical farming,
Mm, mm,
and none of them are very descriptive. They're all really describing little methods, or
yeah.
approaches within the idea of having no windows and no sunlight. And so some of these have multiple layers. Those are the vertical. Some are in shipping containers. Some are
Mhm.
just big warehouse, mostly just big warehouse kind of form factors, but no windows, no daylight, no soil, no wind, no rain.
No, all the things that we equate with agriculture.
And the greenhouses have the same problem except the sun part, but even there, like I said, in many, many, many cases, the lighting is augmented with HID or LED lighting. But
Right.
some greenhouses are, of course, very light in an energy sense or in an industrial sense.
Yeah. And then of course greenhouses are not just used for food production, but they're used for, shrubs and plants and other
Yeah,
other things as well. Your
yes.
paper really hones right in on agriculture, food production.
Yeah, food, and then some exceptions like, stevia is a sweetener. Cannabis is
Mhm.
not a food usually. And so there are a few other things, but it's primarily food products. Yeah.
Right. And then it sounds like well, first off, you can certainly see why you might justify indoor agriculture in a place like the Arctic if you wanted to have for any fresh greens, right? Or any of
Yeah.
the northern climates like that. But
Yes.
but some crops have been seems are you I don't know if you deem them uneconomic, or the industry has things like soybeans and
Yeah.
wheat,
Yeah.
which are, I guess, probably low value crops, need a lot of area.
They need a lot of energy. So that is actually the problem.
Mm, mm,
And
mm.
it's most staple crops. So the crops that, and which is lost often, this is also lost in the literature because there's a huge amount of hype and breathless touting of this method, and unfortunately that's even oozed into the kind of peer-reviewed literature, the kind of formal literature. But the reality is that the crops that are grown that are at all successful commercially are very low calorie crops, very
Mm.
watery, low nutritive value. Lettuce, tomato, I mean, things we want to eat, but lettuce, tomatoes, cucumbers, herbs, microgreens. And microgreens are nutritious, but very low bulk. And most
Yeah.
of the staple crops, like you mentioned, not just grains but legumes, root crops, um, cannot fruits, nuts, cannot economically be grown inside. I'll give you a little one side calculation. I did a bunch of side calculations here just to kind of get arms around things. So there's been efforts. Sometimes they're computer modeled, sometimes they're in person, to grow things like soybeans, and they just pump them, full of light and energy. And the energy used to grow enough soybeans
Yeah.
to provide the protein for you or me, the average human protein for a year, is the same amount of energy as an all-electric home with 2 electric vehicles.
That just blew me away.
It's just
16 megawatt hours, right, to sustain
and
one person's protein requirement.
yeah, and
Wow.
then, there's a lot of ways to look at this. Also, like energy per protein, which gets into the esoteric area of what's the metric, energy
Yeah,
per what? It's a
yeah.
hard problem in this space. It's not just energy per square foot like we're all used to doing with buildings, but energy per protein. This was even more mind-boggling, or similarly mind-boggling. Something like 60 to, can't quite remember, 60 to 100% more energy per kilogram of protein than growing beef. And I didn't get to look at the carbon footprint of the methane side, but I wouldn't be surprised in a kind of average American grid that the carbon footprint was also larger. So it's just a lot of energy because these fibrous crops, these crops with a lot of calories, that's solar conversion, right? So you have to have just extraordinary amounts of electric lighting, and you do need more room, but they're not phased by the idea of growing wheat in 20-story buildings, and each story is 10 feet tall, and there are things that have been penciled out and modeled, and they do that and spend tens and tens of millions of dollars a year on energy hypothetically, but they don't pencil. I think the wheat was something like $6 a pound just for the energy. So you just can't get to market, with something like that. And that doesn't include the $100 million to build the facility and
Right.
labor and all the equipment, all the other costs around it, waste disposal, water. So that's the bottleneck. And that's very fascinating because it means that, like, while there are 23 crops in my paper, meaning in this meta-analysis you mentioned, I came across, these are all leafy greens, different kinds of leafy greens, and different kinds of vine foods and things that we all want, but they're not going to feed humanity.
Right.
So it's
Right.
not a solution to hunger, and it's not a hands down climate resilient solution for the food system writ large, even in the best of
Right.
circumstances.
You mentioned the metrics a little bit. I was interested. Megajoules per kilogram weight. Now that could be kilogram protein too, right?
Yeah, this is marketable weight. So that the metric that I landed on,
Marketable weight.
yeah, because what else are you going to do?
Yeah.
I mean, there are other metrics, like I was saying, but you can't compare across crops unless
Yeah.
you have something like that. But it does bring up, just the sidebar that those of us who work in energy, vanilla, more familiar energy issues. It's typically in buildings, it's energy per square foot, and that's so
Yep.
often how we articulate our power per square foot. But here you don't want to do that. I mean, it is in the paper, and you see similar conclusions, but the yields per square foot vary so much that energy per square foot is important if you're trying to size a solar system or get
Sure.
electrical service or have other things. But really, the efficiency is energy per watt, what you're getting out. And for the moment, you could redo it with calories, and that would be
Hmm.
interesting, but it would be even worse because there's so little calories in
Right. Yeah.
these foods.
Well, and then you mentioned cannabis earlier, the most energy intensive crop of all, at least that you looked at,
Yeah.
23,300 megajoules per kilogram. That's incredible. All of the other crops, I think you had an average uh, energy intensity of, was it 78
For
megajoules?
plant factories, that's for windowless, and then greenhouses get lower. Greenhouses are maybe a third of that. So you have about one, round numbers, for outdoor. So I do have some, they call it open field, again,
Yeah.
this jargon, outdoor grown crops, averaging about a megajoule per kilogram. Variation, all these things vary. I mean, we have 5 orders of magnitude variation in the data that I gathered. But anyway, about 1 for outdoor, about, I think, 20 or 30 for greenhouses, conditioned greenhouses, way less than that for these open or light greenhouses, and then about 3 times more for plant factories, and then about it's a couple hundred times more for cannabis
Unbelievable.
for various
Unbelievable.
reasons. Cannabis is very woody. There's a lot of material that you're producing. Like lettuce, you eat the whole crop except the roots.
Yeah.
Cannabis has a very low ratio of consumable or marketable versus total biomass, and you have to grow all that biomass with the light and the heat and so on, and then very high light levels, a lot of CO2 injected,
Yeah.
very longer growth cycle. There's a lot of factors that conspire to make cannabis particularly efficient, but that was one of the drivers for this paper, because as I'd worked for almost 15 years on the cannabis problem, and the one big question is, like, so how does this compare to other, like,
Yeah.
other
Yeah.
crops? And so this was the first time, and it's very strange, the literature of indoor agriculture, you'll never find a paper about indoor food products that also includes cannabis. You'll never find a paper about cannabis that includes the outdoor. And it's pity, because it's a natural question. And so this is really the first time we've been able to compare a really granular way. And I didn't know whether cannabis would come out at the top or not. It does. Soybeans are not far behind. Wheat is not far behind those crops, but
Oh,
those, of
really?
course, are not marketable. At $2,000 a kilogram, you can afford to spend a lot of energy on cannabis. At
Yeah.
$2 a kilogram, you
Is
can't.
it true that cannabis is the largest cash crop in America?
If you look at the illicit market,
Yeah.
people don't want to know that, but it's true. If you look at the illicit market's about 75%, 2/3
Yeah.
to 3/4 of the total cannabis market still, even in states where it's legal, which is a whole separate podcast. But
Yeah.
it's $100 billion round numbers. Cannabis, I think weed is 20 billion or something. I'm not sure, 10 billion. Yeah,
Well,
it's really.
what was the statistic? I thought that all the cannabis that's grown in CEA, in controlled environmental agriculture, is responsible for the emission of about 10 million cars.
Mhm.
Is that about right?
Yeah.
I
Yeah,
mean,
that's the last paper.
that's
Yeah.
just an absolutely
Yeah, that
enormous.
paper is public domain. It's in a journal called One Earth, published by Cell Press, and did a similar just deep dive into that, and really got to learn a lot about the patterns in that industry because it's very complex, and indoor outdoor greenhouses, legal, illegal, lots of different energy drivers and things. But yeah, it's an enormous carbon footprint, bigger than cryptocurrency, and bigger than a lot of things we would think use a lot
It's
more.
great. It's a really invaluable perspective, Evan. And what are the barriers to making CEA more efficient?
So efficiency has a number of different forms here.
Mm,
There's kind of, you know, your dad's energy efficiency, efficient lighting, heat pumps, things like that. There's process that, I mean, methods to get efficient. There's widgets. There's also
mhm.
process change, and
Yeah,
then there's countervailing things. So just kind of briefly, or kind of conflicting things. So on a technical side, um, it's stuff we can all imagine, the LED lights, the, trying to use some daylight, uh, stuff like that. Most of the studies that I found, these 116 studies were all papers about uh, greenhouse or plant factory growing of primarily food crops, and very high energy penetration of energy efficient technologies. LED lighting is very established. I think 70% of
mm,
the papers I found had LED lighting. Heat pumps are out there. Multiple pane windows are not that common because it's hard to pencil, but it
yeah,
should be looked at.
yeah,
And so that, just footnote, there is a lot of efficiency baked in. But anyway, there's kind of all that stuff. There's also a lot of other energy uses, that are competing. There's snow melting,
yeah,
there's dehumidification, there's post-processing, there's refrigeration. Cannabis uses a lot of energy for refrigeration, and other
mm,
crops do too, because they're overproducing and they have seasonal, ebb and flow and so on. And, if you want to be sustainable and
yeah,
pull water out of the exhaust air stream, then you have to throw more energy at it to get the sustainable water outcome.
right.
Uh, and then, but so there's a lot of constraints on the conventional efficiency, and of course, not unlike what we all grew up studying about the barriers and the frictions. People
Yeah,
don't want to spend the money, they don't trust the information, they have institutional barriers, all that stuff. The surveys are very disappointing of indoor growers, surveys that have been done on interest in energy efficiency. My sample's skewed. I think there's way more efficiency in my sample than the market as a whole, but there's just a lot of inertia to it, and cost benefit. It's people are borrowing enormous amounts of money to build these facilities, and they don't want to. It's just the classic problems of capital cost versus operating. The process efficiency stuff's really interesting. Like, there are things like, I can't remember if it was Turkey or Iran or somewhere, they were growing cucumbers, and it's really hot there, and they were cooling the root zone,
right.
and
Read that.
just
Yeah,
cooling the root zone. And geography, like, there's I can't remember, a factor of 2 or something in energy used for growing tomatoes in Norway, whether you do it southern Norway or northern Norway. And so there's, like, geography. There's people were growing in one of the studies, starting the strawberries outside and
yeah,
then bringing them in. uh, this has got to be mechanized, when you're doing it at scale,
yeah.
which is using more energy. If you're using AI, you're using more energy. All this automation is a problem. But anyway, bringing the not wasting the energy on the runner's stage. So that's pretty interesting, that stuff. And then as I mentioned, there are countervailing things like, there's a lot of studies where they increase the light level.
Yeah.
and see, systematically and see how that does to yields. And often there's diminishing returns and yields actually go down, or you pump, 20% more energy in and you get 1% more yield or something.
Hmm.
So sometimes things are fighting, your things that you think will get your yield up are just costing way too much energy and there's diminishing returns. So it's not exactly
Yeah.
an efficiency convo, but it's part of this quest, what's the least energy per kilogram? And spoiler alert, it's growing outdoors. I mean, the energy used to grow outdoors is way more efficient in terms
Yeah.
of yield and food for people.
Why don't we debunk a few points here? I know that there's some greenwashing of this topic and saying that you're going to spare the land, right? By doing intensive agriculture. Is that true or not true?
It's not true if you want to be net zero. The amount of solar as a multiple of the floor area of the plant factory is can be hundreds of times, tens and hundreds of times the land area of the facility. And so it's usually a losing proposition that way. And with greenhouses, of course, you can't put typically the solar on the roof. I mean, there are certain designs where you can get some. So with the greenhouse, you're immediately using more footprint. And then I was reading recently that there's a lot of land use for the seed production for these
Mm-hmm.
facilities. You kind of got to count that too. But so
And then what about the argument that by using CEA and bringing your food production closer to urban centers, that there's less transportation energy used for food?
yeah, so that's certainly on the very short list of the arguing points. And, the literature isn't great at really looking at that. Mostly people just make strenuous proof by vigorous assertion on that. When you look at the literature, it's one of my kind of uh, lines of discussion here is that the analyses are really sloppy and they're also differentially favoring indoor cultivation, meaning like one of
Mhm.
these papers that asks this question grows the lettuce in Salinas and trucks it to New York. And then the comparison is growing it on the roof of the building where it's being sold in New York.
Yeah.
And both could happen, but neither is. And then they're sending it in a 5 mile a gallon diesel truck. And so there's a lot of assumptions that get baked in underneath these claims if there even is analysis. Not to say that you can't have a situation where that is going to be true, but you got to think about the mode of transport, the fuel, the efficiency,
All those
and
things.
also that in reality, there was one big uh, facility that was serving Walmarts. It was an indoor facility, and so there was hundreds of kilometers of transportation because they were sending this stuff to big hubs. And it's not, you can't just
Mm,
say as a given that it's being sold on site there. So the main energy burden uh, of the whole cycle, I think 50 to 75% of all the energy across these studies is the facility. The
yep, yep.
facility, and the carbon component is even higher, and that's before electrifying transport or these other
Right.
stages of the process.
Now, quite a few big companies have looked at this, I learned.
Yeah.
You said General Mills had a whole project called what? Phyto Farms.
Hmm.
And it sounds like that was they dismissed it, tried to sell it, did sell it. Whoever bought it went bankrupt.
Yeah.
Google, GE, GTE, Sylvania, Weyerhaeuser, they've all made attempts at
Yeah.
CEA.
Yeah, there's been, I mean, the history of this is littered with bankruptcies going back to the 60s. I mean,
Mm,
these proposals early that we were talking about, they were all about earning money and getting investors.
yeah.
And it's just been not to say that there aren't going up concerns, but there's a new paper out by a great scholar at Yale called Mark Bramford, and he's looked at recent bankruptcies. There's been about $10 billion of VC investment in plant factory agriculture in the last decade around the world, 10 billion. And he looked at three here in the States. And I think the aggregate market value at the time of bankruptcies, they all went bankrupt, two within 2 years, one within about 5 years, was I think 3 billion, just for those. And it's, a lot of this is going to come back to the energy spend. Cannabis too. I mean, the cannabis energy's 20-30% of indoor cannabis production of the total cost, including labor. And so it's not surprising for people like us who look at energy and energy spend, and they're usually blindsided by it. They really don't appreciate what they're getting into. And then energy prices go up and things go wrong, and they don't get the total yield that they're supposed to, because everything's
Yeah.
predicated on perfect execution, right? And
Yeah.
let's get
Yeah.
our 25 crops a year of microgreens.
Amazing. So the one thing that I felt, and it wasn't your intent writing this paper
Mm,
to lay out your opinions, but
mm.
after I read it, I thought, what does Evan think? So what is the role? What is there a viable future role for CEA after you've
Mhm.
done all this research? What do you think?
Yeah, so I think, there are places where it's being done and needs to be done. There are places where it has value, can have value. Certain crops, like mushrooms, are all grown indoors, commercial mushrooms. And uh, if you're, if you're so some crops kind of need darkness, not many, but some.
Yeah.
And then you've got, countries that are places that are land constrained. Singapore, I read, it imports 90% of
Yeah.
its vegetables. And their climate, Iceland imports 60% of its food crops. Extreme climates, a lot of CEA is going on in the Mideast, Turkey and Iran and Syria. There's all kinds of papers from Syria and Iran, and it is so hot. And their growing season is the winter, not the summer. They can't grow even in greenhouses. If they're not air conditioned, they can't grow in the summer. Obviously, you mentioned the Arctic. There are CEA stations in Antarctica that are also part of space research.
Mhm.
Submarines, they want to grow in submarines. But all of which is to say, there are certain applications, unfortunately, like in the developing world, where arguably, you know, affordability, food
Yeah.
availability, climate stress are severe. You see almost no literature from the developing world. I don't think I had a single paper from Africa, very
Mhm.
few from South America. And so, there's a lack of skill, capital, energies at a premium. So some of the places that it's needed the most are also the big lift, very fossil intense. There's some experiments with renewables at the polar Arctic sites, but there are also big diesel backup generators there.
I mean, should we have in the United States, should we have standards for CEA? Like we have building standards here? And
Absolutely, absolutely, but nobody wants to talk about it really, or
yeah,
they'll do play footsies with it. There's been
yeah,
some efforts, but it's taken, like, to me, it's optimizing the suboptimal, and yeah, it's gonna happen. I mean, I have the luxury of, being a pundit, and, I don't have to get up in the morning and make these operations run, but I think there needs to be more restraint and more kind of open-eyed analysis and really careful analysis, and the policy community should sink their teeth into more of the finance community should get more energy literate, and do it where you really need to, and look at greenhouses. I mean, it's a spectrum, and even
mm,
having a shade cloth, is a form of controlled agriculture. And I think you might know Larry Kinney in Colorado. You probably know him,
mhm,
and he built, these greenhouses. A really great energy guy from way back. He built these greenhouses at 8,000 feet in outside of Boulder, and had hyper efficient walls and windows and room for solar, and could really get the energy and carbon footprint down. So I think more R&D, more effort on high performance
yeah,
facilities that can provide their electricity from their rooftop or with a very modest amount of footprint, employee parking around it. But I think, there isn't this effort to kind of work backwards from the goal, which might be, net zero cucumbers, and then see what you can do. And obviously, light greenhouses, they have other issues, and you still need mechanical irrigation, and you have salinization problems with the soil because you're sheltering the ground from rain. But light greenhouses are not the problem, in an energy sense. So it's not a
yeah,
black and white finding, but these prodigious, complicated, you know, uh, facilities that are just technological, albatrosses are pretty questionable.
yeah. They're real machines, high tech machines. They're
Yeah,
like
plant factories, I
nuclear
kind of like that
reactors or some
name.
equivalent of growing food.
Yeah.
So, in terms of what would be optimal, I think you would say optimal in many cases is what's been going on for 10,000 years.
And one of the many problems and kind of the sleight of hand, and I would almost call, greenwashing in the analytics and in the commercial positioning of it, is all these comparisons to outdoor grown as this and we're that in terms of energy, water. We didn't talk about water, but it takes more water to grow indoors than outdoors if you count the water in electricity production. I'm not sure about washing solar panels, but
Mm.
hydro for sure. Any thermal power, way more water per kilogram than, yeah, you evaporate less in the
Yeah.
building and you use less for irrigation, but societally you're evaporating all this water outside. Um, but the other thing I was going to get at, the sleight of hand, is that outdoor production or in open field production can also be optimized, and most of the R&D, the investment, the
Mm.
effort,
Mm.
land is cheap, water is cheap until recently, and outdoor agriculture kind of is what it is, and there's been efforts to make it more efficient, laser leveling and whatever, efficient pumps for irrigation, but much more can be done with sustainable agriculture to get more yield. I mean, the sustainable ag approaches that I've studied are yielding about twice as much per square meter with half the water input as industrial, farming. And so that changes the whole baseline,
Yeah.
what you're comparing to. So I
Yeah.
think, working more on making outdoor ag more water, land, and energy efficient is part
Mm.
A, and then making, appropriate sh- uh, shelter, protection. Sometimes people call this protected agriculture. Making that more sensible from an energy and sustainability vantage point is the other. And I think with those two, you can do almost all of it. And then, of course, if you have Inuit people in the north, one of my papers is this Inuit location at 70 degrees north latitude, or 60, I think. And, you know, you cannot grow outside there.
Yeah.
And they don't want to be importing, they're poor and they don't want to be importing food from Spain, with a boat that comes in once a year to these frozen ports.
Mhm.
But there's a lot of diesel power involved too,
I'm
unfortunately.
sure
But,
there is.
do it where you have to. But that's would be a tiny shadow of the 1% of energy it takes today, or the 7% it might take if we went the other
Yeah.
direction.
Absolutely fascinating, Evan. Thank you for educating me and the listeners. I have one final question for you. You are retired. I saw that the paper, this wonderful paper, was not funded by anybody.
Story of my
And
life.
is this the story of this is the story of your life. You are a researcher through and through, or as Amory called you, a synthesist through and through. And that's a terrific thing.
I tell you, once you retire, you can really get to work. I mean,
That's
no meetings,
yeah. Yeah.
no business travel. You can get so much done. It's been remarkable. Yeah, I just follow my bliss, and
Yeah.
not that it wouldn't be nice to have clients who wanted this stuff, but it's great to be your own master, and do it at the speed you want, and take it the directions you want. So to be determined over time. I have other interests outside of energy. I actually grow vegetables too at a modest but intensive scale. And fortunately, it's not all I do, but I enjoy, as long as
Mm.
there are problems like this that just people don't seem to be working on.
Yeah.
There are these edge cases, or they're kind of getting it wrong. I have energy to take a swing at these things when they come up.
Yeah. Yeah. That's really great. Well, you always used to say, ride the wave. You're still riding the wave. Rock on, my friend. Thanks so much for being on the
Thank you.
podcast.
Great talking to you, and thanks for your interest in the topic.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.